This is a calculator that will let us solve problems related to projectile motion. Depending on the problems, they will give us the velocity initial, the theta, the displacement in the x or y axis, the acceleration, and the time. We will have the input, that is where we add the information that the problem gives us, and the output will be used to be able to find the time or the displacement. To be able to do this, we have to first look for the velocity initial in the x-axis and the y-axis. We do this in the x-axis by finding the product of cosine times radians times the theta and times velocity initial. For the velocity in the y-axis, we do the same, but instead of using cosine, we use negative sign. For the velocity final, we will find the product in both cases of negative sign times radians times theta and times velocity initial. To be able to find time, we will use a general formula. In this case, we will use negative velocity initial in the y-axis minus the square root of velocity initial in the y-axis squared minus 4 times acceleration divided by 2 times displacement in the y, and all these will be divided by acceleration. Finally, to find the displacement, we look for the product of velocity initial in the x-axis times time.
The first benchmark determines the range required to hit a target on flat ground. The problem is, I shoot an arrow with an initial velocity of 95 meters per second and at an angle of 36.5 degrees. How far away from a target do I have to be to hit it? The acceleration is negative 9.8 because it is due to gravity. Time is 11.53 and the resulting displacement in the x-axis is 880.67. The second benchmark determines the time required to hit a target on flat ground. The statement in question is, I shoot a compound bow with a velocity of 125 meters per second and at an angle of 15 degrees. How far away from my target must I stand, and how long will it take for my arrow to hit the target? The acceleration is still negative 9.8 because of gravity, and the resulting time is 6.6, and the displacement in the x-axis is 796.88 meters. In benchmark number 3, we are presented with the same problem as benchmark number 2. However, the acceleration changes because instead of shooting an arrow on Earth, I am shooting the arrow on the moon. The moon has a gravity of 1.620. This changed the result of the time. The time is 69.75. The displacement also changed to 5,327.04 meters. In benchmark number 4, we have to determine the range required to hit a target when the projectile lands on uneven ground. The problem is, I kick a soccer ball at 25 meters per second off a 2-story building about 10 meters at an angle of 67 degrees. How far away from the edge of the building do I need to be to hit a target 30 meters from the building? The final result of the time is 5.1 seconds and the displacement is 39.78 meters. The fifth benchmark also tests the time it takes to hit a target when the projectile lands on uneven ground. The problem is, Blastoise shoots his hydro cannon with an impressive velocity of 500 meters per second. If his opponent is standing on a cliff 50 meters above him, that is 100 meters away, and he is aiming at 58 degrees above horizontal, then how long will it take his shot to hit his opponent? The resulting time is 86.65 seconds. The next problem is as follows. Imagine you run and jump off a 12-meter waterfall and you jump at 15 degrees with a velocity of 7 meters per second. How far from the waterfall will you land, and how long will you be in the air for? It would take 1.7 seconds and 11.9 meters.